There is a single point of light buried in a Hubble image, and somebody gave it a name: Earendel. One star, 50 to 100 times the mass of the Sun, its surface burning near 20,000 degrees. Its light in transit 12.9 billion years before landing on a mirror in orbit above your head. The agencies called it a record. It is a record. It is also, in a sense, a receipt, because a star that heavy does not last. Burn that hot with that much mass, and you get a few million years, not billions. So, Earendel has been dead for roughly 12.9 billion years. Whatever you are looking at in that pixel, it is not a star. It is an invoice from something that stopped existing before the Sun formed, before the Earth cooled, before there was anywhere for a person to stand. Now, 3 facts. Fast. That object sits around 28 billion light-years away today, and nothing we build will ever reach it or hear from it again. We only saw it because a cluster of galaxies happened to sit in the way and magnify it 1,000-fold. That alignment is temporary. It drifts. And every time we push deeper into that early universe, our best model of how it all assembled performs worse, not better. So, here is the thesis, up front instead of saved for the end. The distance record is not the story. The story is that we are collecting evidence that is being permanently deleted while we collect it. And the framework we use to read that evidence is cracking at exactly the same depth. Those two things are happening together. Almost nobody says them in the same sentence. Before I go further, I want to know something. Where are you watching from, and what time is it there? Drop the city below, and be honest about this one. Had you ever heard that the farthest star humanity has ever seen no longer exists? I ask because that gap is the whole problem. The distance between what was published and what people absorbed is where this story lives. The public version of Earendel was a triumph. New record. Deeper than ever. Webb will do better. All true. All incomplete. Read the second paragraph of the press release and the tone shifts. Read the papers underneath and it shifts again. What sounds like a milestone starts sounding like a measurement of how narrow our window is and how fast it is closing. That is where we are going. Not toward wonder, toward the arithmetic underneath it. And what that arithmetic says about how long any of this stays visible. Start with the official language because it is careful and almost nobody reads it carefully. When Hubble found Earendel, the European Space Agency described a huge leap back in time. Accurate. When Webb pushed further, the coverage kept the same shape. Record broken. Frontier extended. Deeper than ever. In 2025, a team announced a galaxy called MOMZ-14 at redshift 14.44, sitting only 280 million years after the Big Bang. It cleared peer review in January 2026. The title of the paper was A Cosmic Miracle. Sit with that title. Scientists do not use the word miracle as decoration. In a technical paper, that word is doing a job. So are the words that keep appearing around these discoveries. Surprisingly luminous, brighter than predicted, unexpectedly massive, more common than the models allow. In everyday speech, those read as excitement. In physics, they mean one thing. The prediction failed. Before Webb launched, the practical ceiling for confirmed galaxies sat around redshift 10. Webb cleared it within months and kept climbing. That is not a better camera. That is the discovery that the early universe was assembling large, bright structures faster than the standard picture said it could. Then, in March 2026, came a galaxy called GS-Z11-0, red and dust-rich at redshift 11.45. Dust is the leftover of dead stars. Finding it that early means whole generations of stars had already lived and died inside a window the models treat as barely enough time to begin. Here is what I am not saying, and I want it plain, because this subject attracts people who will twist it. I'm not saying the Big Bang is fake. I'm not saying cosmologists are lying, or hiding results, or protecting a story. The people finding these objects are the same people publishing the anomalies. That is the system working as designed. What I am saying is narrower and harder to dismiss. The observations are outrunning the model, and the public only received the half of that sentence that feels good.
Watch how the two halves travel. The record goes into the headline, the news segment, the thumbnail. The anomaly stays in the abstract, in the discussion section, in the conference talk where somebody says we may need to revisit early star formation efficiency, and the room nods. Both are true. Only one of them reached you. Once you notice that split, you cannot read one of these announcements the same way, which raises the obvious question. Why should seeing something too early break anything? To answer that, you have to understand what distance actually means out there, because it is not one number. Ask how far away Earendel is, and you get several answers, all correct, none of them the same. That is not sloppiness. That is the physics. The universe is 13.787 billion years old. Light from Earendel traveled 12.9 billion of those years. So, the intuitive answer is 12.9 billion light years, and it is wrong because space did not sit still while the light crossed it. The usual analogy is an ambulance siren dropping in pitch as it drives away. Useful for 30 seconds, then throw it out, because it implies the object is moving through space, and it is not. Space itself is expanding everywhere, between everything. The light was not chasing a fleeing star. The road underneath it kept getting longer, while the light was still on it, which is why the observable universe has a radius of about 46.5 billion light-years, despite being under 14 billion years old. Nothing broke the speed limit. The distances grew. Earendel sits roughly 28 billion light-years out today. Notice what that means. The gap between when we see it and where it now is larger than the age of the universe. Translate that into something you can hold. Someone writes you a letter, then starts walking away. By the time the letter arrives, they are not where they were, and they are not walking anymore. They are standing on ground that keeps stretching faster every year. You can read the letter. You cannot reply. You cannot follow. You will never learn what happened after they sealed the envelope. That is what redshift really is, not a Doppler trick, a record of how much the road stretched underneath the signal in transit. Redshift 14.44 means the light arrived stretched more than 15 times over. Ultraviolet left the source. Infrared arrived here. The photons carrying the news are exhausted by the time anything counts them. And here is the part that gets skipped in every explainer. That channel is not stable. It is not a permanent feature of the universe sitting there for whoever comes next. It is closing. Every year the stretch is greater. Every year distant objects dim further and shift redder. The letters keep arriving, but the paper is thinning, and eventually the ink runs out. We are not standing at the beginning of an era of deep observation. We are in the middle of one, and the exit is a real physical thing. Before we get to how that exit works, there is a smaller and more uncomfortable fact about Earendel. The only reason we saw it was never something we controlled, built, or earned. Webb did not find Earendel, neither did Hubble, not really. A cluster of galaxies found it. Put enough mass in one place, and it bends space around it. Light passing through that bend gets deflected, and if the geometry lines up, focused. Astronomers call it gravitational lensing, and inside every lens there are thin lines called caustics, where the magnification spikes to enormous values. A star sitting on a caustic can be brightened 1,000-fold, sometimes far more. Off that line, it is invisible. On it, it is a detection. Earendel sits on a caustic line. That is the entire reason it exists in our data. The previous record holder tells the same story. Icarus, redshift 1.5 from a universe 4 billion years old, published in 2018. Icarus became visible because a compact object inside the foreground cluster drifted across the line of sight and briefly spiked the magnification. Then it faded. It was a flare in the geometry, not a steady source that patient observation pulled out of the dark. Every distance record for an individual star has come this way. Not one was achieved by telescope power alone. Not one. So, the honest sentence is uncomfortable. Webb is not why we can see individual stars at cosmic dawn. Luck is. Webb is why we can confirm and study what luck hands us. Now, here is the part that should bother you. Caustics move. Clusters are not static sculptures. They are thousands of galaxies orbiting each other, and every mass inside tugs the lens out of shape. The alignment that lifted Earendel out of the background glow is a temporary state of a system in motion. It will drift off. Some of these events last years, some last weeks, which means the data is not repeatable. Think about what that does to normal science. The method depends on somebody else checking your work by looking again. Here, looking again may not be available, not to a rival team, not to a better instrument, not to a smarter generation 50 years from now. The event happened. We recorded it, and the recording is all there will ever be. We are used to treating the sky as an archive that stays open, a library that will still be there whenever we get around to it. It is not. Parts of it are performances, and we caught a few of them mid-show by accident. The instinct here is reasonable. Fine. Stop relying on flukes. Build something bigger. Collect more light. Brute force the problem the way we always have. That instinct is exactly where the physics stops cooperating. And it does not stop gently. It stops at a wall. The intuition says distance is a dimmer switch. Twice as far, somewhat harder, build a bigger mirror. That intuition is wrong in way that changes the problem. Brightness falls with the square of distance, and in an expanding universe, the distance that matters grows far, far faster than travel time. Then stack the redshift effects on top. The light arrives stretched, so the energy in each photon drops. The photons arrive spread out in time, so the rate drops too. For an extended object like a galaxy, surface brightness falls as 1 plus redshift to the 4th power. Push from redshift 6 to redshift 14, and that term alone is roughly a 15-fold penalty. So going from Earendel at 6.2 to MOE-MZ14 at 14.44 sounds like doubling. It is nothing like doubling. In photons actually collected, it is a collapse, and you claw it back only by stacking advantages. A cluster in precisely the right place, a caustic line, an object bright enough to be freakish, hours of exposure to gather what a nearby star delivers instantly. That is why every one of these records has a coincidence attached. There is no other way to buy the photons. Push further, and the problem stops being difficulty at all. Rewind to before any star had ignited. The universe was neutral hydrogen, dark, expanding, and nothing emitted visible or infrared light because nothing had switched on yet. Astronomers call it the Dark Ages, and the name is literal. You cannot photograph a room with no lamp in it, not with a bigger mirror, not with more exposure, not with better software. There is no signal to collect. That is a category change, not a difficulty change. Everything else in this story is about instruments being small. This is about light itself having nothing to carry. There is one way around it, and it is not a telescope. Neutral hydrogen emits at 21 centimeters in the radio. Catch that faint signal, and you could map the Dark Ages without a single star. The problem is that the signal sits buried under galactic foregrounds thousands of times stronger, and the cleanest place to listen is the far side of the moon, shielded from the radio noise of our own planet. Missions have been proposed, prototypes have flown. A real map is decades away, and decades assume the funding survives politics. So the honest map of what we can see looks like this: a narrow band of extreme distance, reachable only with luck. Below it, a floor where light stops working. Above it, our own limits. Which brings us to the smallest and strangest constraint in this story: the observer. Strip away the metaphors, and here is what a deep field is. A cold mirror 1.5 million kilometers from Earth, counting individual particles of light. Not imaging, counting. At these distances, the arrival rate is so low that detectors sit open for hours and register photons essentially one at a time. And the picture exists only because you add thousands of those arrivals and subtract the noise. A dark, adapted human eye can register a flash from a handful of photons landing on the retina at once. Webb needs hours of accumulation to say anything at all about these targets. Your eye is a better instrument than Webb right up until the signal gets faint, and then the comparison stops being funny. The deepest exposures run tens of hours on a single patch of sky. Some programs run hundreds across many visits. Translate that: a full working day of staring at one dark rectangle, repeated and repeated to produce a smear that a team will then argue about for 2 years. A deep field is not a photograph. It is a stack of patience. And there is a detail I keep coming back to. The photons that ended their journey inside that instrument left their source before the sun existed. They crossed the entire history of the solar system while in flight. Then they hit a sensor smaller than your hand and stopped. That is where the journey ends. Not in a discovery, not in a headline, in a silicon well converted into a number. Now put a human timescale beside it. A researcher gets a handful of observing programs across a career if they are fortunate. Telescope time is oversubscribed by factors of 5, 6, sometimes more. Proposals are rejected. Cycles are annual. A candidate object flagged at redshift 14 may wait years for spectroscopic confirmation. And that confirmation may. MOM Z14 was announced in 2025 and peer-reviewed the following January. That is fast by the standards of this field. It is also a reminder that every step here runs on the clock of institutions and human bodies, not the clock of the universe. The generation collecting this evidence will not be the generation that understands it. That is not pessimism. That is simply how the intervals work out. And all of that would be survivable if the collecting could simply continue, if the instrument were permanent, if somebody could always take the next exposure and the one after that, for as long as the questions kept coming. Except the machine doing the counting has a tank, and the tank has a bottom. Webb does not orbit Earth. It sits out near the second Lagrange point, about 1.5 million kilometers away, holding station in Earth's shadow so its mirror can run close to absolute zero. That location is the reason it works. It is also the reason nobody is ever going to fix it. Hubble was different. Hubble launched in 1990 with a flawed mirror, an error that could have ended the program, and astronauts flew up and corrected it. 5 servicing missions across 19 years, new instruments, new gyroscopes, new solar arrays. Hubble is still producing science 3 decades later because human beings could physically reach it and put their hands on it. Nobody is flying to L2 with a toolkit. Webb runs on the propellant it launched with. A tighter than expected launch left extra fuel in the tank, and estimates now run past 20 years, which is good news. It is still a number with an end attached. When the propellant runs out, the telescope drifts off its pointing and the mission stops. No repair, no refill, no second attempt. So, what replaces it? Roman launches soon, and Roman is superb. But Roman is a wide survey instrument. It maps large areas of sky quickly. It is not built to stare at one caustic line in one cluster for 30 hours. Different job. The observatory meant to succeed Webb in raw depth, habitable worlds is a 2040s proposition, and the 2040s are subject to budget cycles that have already killed flagship missions before. We have watched this happen repeatedly. The superconducting super collider was cancelled with billions already spent and a tunnel in the ground. Apollo ended with hardware built and flights on the schedule, and half a century later, nobody has repeated it. Arecibo, the largest single-dish radio telescope on Earth for 50 years, was left with degrading cables until it collapsed into its own bowl in 2020. That is the pattern. And it is the least discussed fact in this story. Capability is not cumulative. We assume it accrues, that each generation inherits everything the last one built and adds a floor on top. It does not work like that. Capability is something you fund, maintain, defend, and can absolutely lose. Here is the shape of the situation. Humanity's deepest view of the universe currently depends on one unserviceable machine parked at a location no human has ever visited, running on a finite tank with no equivalent successor confirmed. One window, one bolt holding it open, which makes the tone of the public conversation genuinely strange. If that is the situation, why does everything coming out of the agency still sound so relaxed? Because the vocabulary is doing work. Take the clearest example. Measure how fast the universe is expanding using the cosmic microwave background and the standard model, and you get about 67.4 kilometers per second per megaparsec. Measure it locally, climbing the distance ladder through Cepheid variables and supernovae, and recent work combining Webb and Hubble gives about 73.8. The uncertainties are half a point and under a point, respectively. Those numbers do not overlap. They are not close. Depending on which data sets you combine, the disagreement sits between 5 and 6 sigma, well past the threshold where you stop calling something a fluctuation. The name for this is the Hubble tension. Tension, not contradiction, not failure, not crisis. Tension, like a slightly awkward dinner. That word has held for over a decade while dozens of teams attacked the problem from every angle, and the honest summary is that the gap has not closed. Systematic error was the obvious suspect, and Webb was supposed to settle it by remeasuring the latter at higher resolution. It confirmed the local number instead. I want to be careful here because there is a bad version of this argument, and it is popular. The bad version says scientists are hiding something. They are not. Every figure I have used comes from their own papers and their own press releases. Their caution is correct practice, and understatement is what stops a field lurching after every anomaly. If they announced a crisis every time two measurements disagreed, they would be useless to everyone.